I'm going to highlight some of the more important points from this chapter, chapter 14, but make sure you do read the entire chapter because I'm not going to cover everything. The Chesapeake Bay is a good example of where we have some water issues. So it's the largest estuary in the U.S. You can see the watershed here that I'm outlining encompasses some very highly populated areas. So all the land area drains into the Chesapeake Bay. Chesapeake Bay is an estuary where the fresh water mixes with the salt water, which is a really important area for a lot of aquatic organisms. Now, one problem that we see in the Chesapeake Bay is that there's a lot of nitrogen and phosphorus that's running off into the area from sewage treatment facilities, CAFOs, fertilizers on agricultural fields, and so we end up with algal blooms. The algae eventually dies, using up the dissolved oxygen in the water, leading to dead zones because organisms can't survive in the water without the oxygen. Another problem is increased sediment. So as water drains from that watershed into the bay, it's picking up sediments from agricultural fields, from areas that have been deforested where the soil isn't staying in place, and also degraded riparian areas around rivers and streams that have lost their vegetation, maybe from development or from agriculture, from livestock that use that area. This clouds the water, clogs up fish gills, may settle to the bottom and clog the gills of oysters and clams. So it's a big problem. It also, you can see, just makes the water really a muddy brown. Finally, there are a lot of chemicals, man-made chemicals that get into the water, such as pesticides, pharmaceuticals, and these have the ability to cause some physiological changes in aquatic organisms. They're seeing higher rates of hermaphroditic fish in some of these areas, so it does some screwy things. Lake Washington is another example of an area where there's been some water pollution issues. So Seattle is here. I grew up in Bellevue, which is right over here, and there's a big, really, really deep lake separating those two sides. It's formed by glaciers, so if you've ever been in this area, these bridges that cross over, there's another one over here, are actually floating because they're way too deep to have supports that hold them up. Now, starting in around 1900, development really began around the lake, and the wastewater treatment facilities that existed at the time would just dump all the waste into Lake Washington. It is so deep, there's so much water in there that the water could easily dilute that human waste. Unfortunately, as the area and population expanded, more and more waste was being dumped into Lake Washington, which increased the nutrient levels in the lake. They experienced a lot of algal blooms. The lake got stinky and green and gross, and there would be fish deaths, and it just wasn't safe to swim anymore. It was also just unpleasant to be around. So now the wastewater treatment facilities dump water into Puget Sound, which is ocean water, which circulates and disperses that waste much better. Now, after big storm events where there's a lot of water going into the drains, some waste does still go into the lake. So occasionally there are these warning signs when you're not supposed to eat the fish or swim in the water because of that sewage that goes directly into the lake every once in a while. When we're talking about water pollution, most often people think of things like chemicals that get into the water, but it does also include things like sediments, heat, and noise even. Now, some sources of pollution come from point sources, and these are things like an individual factory that we can actually point at and say, okay, this type of pollution is coming from this one area, from this particular factory. They're easy to identify, monitor, and regulate. Also, non-point sources. Non-point sources are coming from broad or diffuse areas. They're really hard to identify. So, if there's an area with a lot of agricultural fields, maybe pesticides are running into the stream, but we can't just pinpoint one particular field where all those pesticides are coming from. So it makes it really hard to control these types of polluters, and really expensive to clean up as well. So the leading causes of water pollution, agriculture activities are way up there on the list. They contribute to a lot of the sedimentation or sediment that ends up in our waterways. They're contributing to the fertilizers and pesticides that get into the water, as well as bacteria and organic compounds from livestock and food processing. Industrial facilities also produce a lot of waste, so power plants, especially coal-burning power plants, are producing coal ash, which contains a lot of toxic materials, including heavy metals that can get into water. It can also cause acid precipitation and acid drainage into groundwater. Fracking, which we talked about a little bit, also injects a lot of chemicals into the rock to break it up and bubble out natural gas, and that could possibly get into groundwater. And then a lot of industrial processes use water, fresh water, or any water really, to cool down their machinery, and then that water heats up and they discharge it back into that waterway much warmer, which isn't good for a lot of organisms living in those areas. And then finally, mining just exposes water to toxic heavy metals that might have been in the rocks naturally, but then they are much more available to water once they're mined. And those sediments also erode away once that rock is all broken up. There's also waste in water, physical waste that pollutes water. So a lot of that's coming from dumping directly into water. Some gets free from landfills, but that can be a problem in fresh water as well as ocean water. In the Pacific Ocean, we know that there's a very, very large gyre basically circulating with hundreds of millions of kilograms of mostly plastic, very small pieces of plastic just under the surface of the water. We used to think that all of that garbage that went into the ocean would just kind of disintegrate and disperse, but it's not all doing that. Plastic especially takes a long time to biodegrade, and it's very dangerous for aquatic organisms. One other issue I want to talk briefly about has to do with decaying of degradable waste. So a lot of this is either human or animal waste that gets into waterways. It's organic, and so bacteria are going to start breaking this stuff down. So here's a point source of this organic waste, and then bacteria come along and start degrading that, biodegrading it. Well, that uses up a lot of oxygen. So the biochemical oxygen demand, or BOD, increases dramatically because those bacteria are using a lot of oxygen to break down this material. So that means the dissolved oxygen in that area is going to decrease rapidly. So a lot of organisms can't survive without that dissolved oxygen in the water. Now, as we get further away from that source of the biological waste, organic waste, we see that the levels do finally go back to normal here as that water disperses, or as the waste disperses and is eventually broken down. Now, as far as the global outlook, things look better in the developed world than in developing countries. So in developed countries, Most have done a pretty good job at reducing point source pollution because they've created good laws and regulations to limit the amount of pollution that can go into our waterways. So in the United States, the Clean Water Act of 1972 is an important law that regulates the amount of, some different types of chemicals that go into our natural waterways, and also looks out for aquatic organisms in those waterways. Also, the Safe Drinking Water Act is important in regulating the number or the concentrations of some different chemicals that can be in drinking water. They don't regulate non-point sources of pollution, so those are still a big problem. But not as big as a problem as most pollutants are in developing countries. You can see that half the world's 500 major rivers are polluted. A lot of that is coming from untreated sewage that goes directly into surface water, not going through a wastewater treatment plant. There's a lot of industrial waste coming from factories. And the sad thing is, people are relying on this water that's often so dirty, so polluted for drinking, for bathing, for washing. Over 1 million people don't have consistent access to safe drinking water. So you can see what things might look like in China, in Peru, where they are dumping garbage directly into the waterway. In a lake in China, all of that, the pollution that gets into the waterways causes cultural eutrophication, which can lead to fish kills. Another example of where we potentially have a big problem is in the Great Lakes. So again, we have some large cities that do surround the Great Lakes, and the lakes are experiencing increasing pressure from these areas and the large numbers of people and industry. There used to be some huge problems with cultural eutrophication, but in the 70s, the U.S. and Canada came together to come up with a pollution control program, and it's been relatively successful to really clean up the water, kind of curb the eutrophication that was occurring. Some of those, the big things are bans on phosphate-containing household products like detergents, better sewage treatment plants, fewer industrial wastes. And there still are problems there, especially with non-point sources of pollution, but things are getting much better. Groundwater pollution is also a big problem because we use it as a source of drinking water in many places in the U.S., but the water actually moves very, very slowly, and chemical reactions occur very slowly. So these pollutants don't get diluted very well and don't break down very well. So you can pause it on this slide if you want to take a look at some of the sources of groundwater contamination. Ocean pollution is also a huge problem. I mentioned the Pacific Garbage Patch, which is evidence that, if we dump it in the ocean, it's not just going to go away. Is definitely a persistence to some of those substances that we put in the ocean. We talked about this sort of dead zone off from the Mississippi River in the Gulf of Mexico, so I won't spend any more time on that. Oil is also a really big problem in the ocean. Now, a lot of oil does seep out of the ground naturally, but one of the biggest man-made sources of, or human-caused sources of oil in the oceans is actually just runoff from industry in urban areas. Think about if your car drips onto the road or in parking lots when there's a storm, that water is going to flow right into the ocean. There are chemicals in the oil that can kill a lot of aquatic organisms. The oil at the surface coats animal fur and feathers and weighs them down. It also makes it so they're not insulated anymore, so they get too cold. They can also drown. And then parts of the crude oil also sink to the bottom of the ocean and affect the bottom dwellers. So the Deepwater Horizon blowout in 2010 was one of the larger oil spills we've had recently. You can read about it in your book. Just a couple days ago, there was also a tanker that spilled quite a bit of oil. So, this is something that does occur pretty often. The Exxon Valdez oil spill in 1989 in Alaska is also a very, very well-known oil spill, probably the worst in the U.S. So please make sure to read about that in your book. Also, I didn't cover wastewater treatment plants, primary treatment versus secondary and tertiary treatment, so make sure you do study those because those are important concepts.